All right, so welcome to your first online day. I was gonna do, like if you were in class, I would say, are there any of these you need a hand with? It's hard for me to predict, like I suspect there's probably some of you screwing up the negatives in front of the brackets because you're multiplying it through before, the negative in before multiplying. Don't do that. No, they do not all have to work out to be whole numbers. Number 9 will be a quadratic. But maybe if there's any of those that are messing you up, how about put a message in the messenger group, and then I'll know which ones you want me to discuss. Remember down here, these ones are a little trickier than grade 11, but remember you need to get the x by itself, so the first one shouldn't be a problem. Remember that when it's when there's an x and an xy, that you need to take them to the same side and factor it out. Okay, so again, the same thing goes. If there's any of these that mess you up, just list them in the messenger group, and then I'll know which ones I should help you with before I see you again. On the back side, and you may not have gotten there yet, so let me just talk about it for a minute. So it says perform the indicated operation or solve for the unknown. So in number 1, you're going to solve for k. So what should you do? Maybe take the 3 over and combine it with the 3/4, and then you'll have a fraction on each side and cross multiply. I might do that. Down here you're solving for x. I'd probably get rid of the fractions first off. Here you're adding the fractions together. Show me the work. I know your calculator can do it, but you are not allowed to leave this building until I know you can do it. Here, remember, dividing by a fraction is the same as multiplying by the reciprocal, but the bottom isn't a single fraction yet. So you got to put it into a single fraction first before you can flip it and multiply. When you get to exponents, your final answer should not have a negative exponent in it. So my questions are allowed to have a negative exponent, but the final answer shouldn't. And I think you've done exponents. So this negative exponent here on this 4b to the negative 3, that's really then the same as 4 over b cubed. The negative means take it to the denominator. So, and the same would happen here. Before I move things to the denominator, though, I would probably multiply the negative 3 in. Again, please put in the message group if you've done these exponents. I think it's grade 11, but I'm not giving these to you to be mean. I just thought they were a review. Okay? So your only homework for the next time I see you will be this math sheet. What we're going to do new today will not have homework connected to it until we get a bit further in. Okay, so not new yet, but a review is vectors. So we're going to talk about vectors for the first few days here. And if you remember, a vector is something that has both a magnitude and a direction. And so it might be something like displacement, it might be something like velocity or force or momentum. Usually the length of the shaft of the vector tells us how big it is, how big its magnitude is, and the direction that the arrow is pointing in tells us what direction it is. So this might be, I don't know, 10 newtons east. And if it is, then this would probably be something like 4 newtons north, right? So 4 is shorter than the 10, and it's pointing east and north, okay? And so the first piece we need to review today then is adding vectors. And you did these in grade 11. And if you remember, there are 4 cases for adding vectors. Case number 1, and the first 2 for sure, and even the third one, they're borderline common sense. So case number 1 is when the vectors are going in the same direction. Okay, so let's imagine I have my 4 Newton vector, and it's going east. And I have a 3 Newton vector also going east. Okay, what are the rules? The rules are, the math rules are, you add them and keep the direction. Borderline common sense, right? If you're pushing with 4 newtons on a box and someone else is pushing with 3 newtons on the same box in the same direction, The resultant, the vector you get as a result of adding them, would just be added together. Graphically, the rules are, remember, you have to put them head to tail. And then the resultant starts where the first one started and ends where the last one ends. And so it would be 7 newtons east. What's the angle between these two vectors, the 3 newtons and the 4 newtons? It's 0 degrees. Okay, so the rule, add them and keep the direction when vectors are going in the same direction or 0 degrees. Case 2, again, borderline common sense, when they are opposite directions. So this time you're pushing with 4 newtons east, but your friend decides to be not helpful, and they're pushing with 3 newtons west. Again, common sense would say, what do you get as a result? You should get 1 newton. Okay, what's the rule? Again, mathematically, the rule is, so this is add and keep directions. This one is subtract and keep the direction of the larger. Okay, what do? Again, you still have to line them up head to tail. The tail of the second one has to be on the head of the first. Whoops, maybe not drawn to scale there. So this is my 4 newtons east. This is my 3 newtons west. And the resultant always, 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 always starts where the first one started and ends where the last one ended. And so the answer here would be, the resultant here would be 1 newton in the direction of the bigger one, so 1 newton east. Okay? So again, like I said, these two are borderline common sense. What's the angle between opposite directions? 180 degrees. Case number 3 is when they are at right angles to each other. In other words, 90 degrees. So now you're pushing on the box 4 newtons east again, at least you're consistent. But your friend this time is pushing 3 newtons north. They just can't decide what direction. Okay, before we can add these up, they have to be head to tail. And so you have to either take your 3 newton one and slide it over so that it's head to tail with the 4 newton. So you could slide it over here. And this would be your 3 newtons, still north. Or I need another color. I don't want to use red. Shoot. Don't know what color this is, but I think it's a highlighter. Or you could take your 4 newtons up and put it up here. In either case, the resultant is still going to start where the first one started and end where the last one ended. So both of them start here, both of them end here. The resultant is going to be in the exact same spot, so it doesn't matter which one you move. How do you find it? Pythagorean theorem. 3 squared plus 4 squared, take the square root. This is going to be 5 newtons. And what's going to change will be the angle. So if you moved your 3 over, you would find this angle. If you moved your 4 up, you would find this angle. Okay, how do you find the angle? Tan. So it would be inverse tan of 3 over 4.75. So this angle is going to be 36.87 degrees. And then remember, we go 5 newtons square bracket. We were going north first, we were going east first, and then we turned 36.87 degrees, and we went north. That would be for the blue one, which I should have written in blue, but that would have made too much sense. Okay? If you had moved the 4 up, then it would be 5 newtons square bracket, and it would be this angle, which will